This is revision for higher maths. It's the straight line assignment and we've got 9 questions that we're going to be looking at here. For the first video I'm going to cover questions 1 through to 6 and then I'll have another 2 videos after that to cover the rest of the assignment. If you haven't seen it before and I didn't give you this assignment, then what you can do is freeze the video at the questions, try and answer it and then see what the solutions are. Right then, let's go from now, okay? First question. So what we have to do is to find the gradients of the lines between the following sets of points. Okay, so I've got point A and I've got the point B. So if I'm trying to work out the gradient, I know the gradient formula. The gradient of AB is going to be equal to y2 minus y1 all over x2 minus x1. Now I'm going to label these points up. So there's my x1, y1 and there's my x2, y2. I'm just going to be using these points here and substitute it into the formula. Here we go. So I've got 10 take away 8 all over minus 4 take away 2. And I'm just going to evaluate the work from here, just work out the answer and get my gradient. 2 on the top, I've got minus 6 on the bottom, simplify it down to minus a third. First one done. Part B, I've got the points P and Q, so I'll work out the gradient of PQ. Same type of thing, y2 minus y1 all over x2 minus x1. This here is x1, y1, and this one here is x2, y2. Right, substitute the points in. So I've got 2 minus minus 6, I've got minus 1, and I'm going to substitute, take 3 away from that there, okay? Right, so I've got 8 on the top, minus and minus is a plus, and from here I've got minus 1 plus 3 is going to give me 2. So that there's going to give me a gradient of 4. Okay, so that's question 1 complete. Let's look at question 2. Right, so question 2. The points E and F have coordinates 2 minus 5, minus 4, A respectively. So we know the gradient. The gradient's given as 2/3. We have to find out the value of the missing letter here, so A. Right, so what we're going to do there is we're going to know the gradient formula. So the gradient of EF is y2 minus y1 all over x2 minus x1. Okay. I know that that there is equal to 2/3, so I'll just write that in there. What I'm going to do is I'm going to substitute these values in. So I've got x1 and I've got y1, I've got x2 and I've got y2 here. Substitute these values in and the letter in and we'll just work out the value of A. Right, so starting there, I'm going to go for A minus minus 5 all over minus 4 take away 2, and that's going to be equal to 2/3. So that's going to be A plus 5 all over minus 6 is equal to 2 over 3. What I'll do is to get rid of this 6, first of all, I'm going to multiply it up at the top here. So that's going to give me minus 12 over 3, and that works out to be minus 4. So what I've got here is A is equal to minus 9. Okay, just taking this type of question just a step further. So what we've got 3 points and we know they're collinear and we have to find the value of K. So what I'm going to do is similar to what I did in question 2, I'm going to do the same kind of thing. The only thing is here I don't have a gradient given. So I'm going to make this the point A, I'll make this the point B, make this one the point C. So I know that for collinearity, I know that the gradient of AB should equal the gradient of BC, and there I've got a common point B between these here. Right, so let's work out the gradient of AB first. I've got all the numbers for that, so I should be able to work out the gradient of AB. y2 minus y1 all over x2 minus x1. I'm going to take a 0 there, minus 2 and a minus 1, take away the 3. From there I've got minus 2 all over minus 4, so that will give me a gradient of a half. From that I'm going to be looking at the gradient of BC. Okay. Gradient of BC, I'm going to do the same thing, y2 minus y1 all over x2 minus x1. I've now got the gradient of AB, and for collinearity I know that these gradients are going to be the exact same, so that's going to be equal to a half. start with here, I've got k minus 0 all over 4 minus 1, and that's going to be equal to a half. So I've got k minus 0 all over 5 is equal to a half. What I'll do is I'm going to take that 5, multiply it up to the other side, so k is going to be equal to 5 over 2. That's going to be my final answer. Or, if I change that into a mixed number, it'll be 2.5, and that'll probably be the answer that's given in the questions. Okay, so that's questions 1, 2, 3 complete. Let's have a look at question 4. So in question 4, it's split up into a number of different questions. We get A, B, C, so let's go ahead with the first one, part A. Right, we have to find the equation of the line that passes through the point P with a gradient of 4. Okay, so I'm going to substitute gradient equal to 4 and the point P, 2 minus 3, into general equation of a straight line. Okay, so this isn't given in the formula list. You need to remember this, and this will be something that you've already covered over your National 5 time. So let's go ahead and substitute our values in. Value for m, or the gradient's 4. This here will be my a value, and this will be my b value here. Just going to substitute them in as they are. So y minus 3 will make a plus 3. I've got 4 for m, for the gradient, and for a, I've got 2. What I'll do is I'll multiply out the right hand side, so that's going to be 4x minus 8, and what we have here is y is equal to 4x, bringing that 3 across will give me minus 11. So that's going to be y is equal to 4x minus 11. For part B, I've got to find the equation of the line passing through 2 points. So I've not been given the gradient, but I can work out the gradient between these 2 points here. So my gradient of AB is equal to y2 minus y1 all over x2 minus x1. Values going in, I've got minus 1 take away 1, and I've got 3 take away minus 1. Gives me minus 2 all over 4, which gives me a gradient of minus a half. Right, so what I'll then do is I'll substitute. I'm going to substitute gradient of minus a half, and I can pick any of these 2 points here. Okay, so I'm just going to pick the point B. I'm going to go for that one. Okay, doesn't matter which point you substitute in, we should get the same answer coming out from here. Right, we're going to substitute it into y minus b equals mx minus a. So y minus, and it's minus 1, so I'm going to make that plus 1 there. I've got minus a half x minus 3. Okay. Right, so I'm going to try and work this out. I'm going to take that 2. The way I would get rid of this fraction, whatever's on the bottom there, I'm going to multiply the left hand side, both parts, by that. Okay, so that's going to give me 2y plus 2. I'm then going to attach the minus sign to the top and multiply out the bracket. So that's going to give me minus x plus 3. I'm then just going to reorder it for that. Put the x over to that side to make it a bit tidier, bring the 2 over to that side there, and that should give me a 3 minus 2, which gives me a 1. So the answer there would be 2y plus x is equal to 1, or any other kind of combination of that you've got. Right, let's look at part C. Right, so we're looking for the equation of a line passing through that point there, and it's parallel to the line with equation 3x plus 2y equals 8. Okay, so try not to make the mistake of just grabbing the number that's sitting there in front of the x as your gradient. That's not the gradient of this line here. Okay, let me show you what the gradient is. Because I need to get the equation in the form of y equals mx plus c to try to grab the gradient from there. Right, so let's change this about a bit. So I'm going to take that line there first of all, and what I'll do is I'll take the 3x over to the other side, and I've got plus 8 there. I'm going to then divide each of these by 2, so y is equal to minus 3 upon 2x plus 4. So I've now got it into the form of y is equal to mx plus c. I'm going to grab that there, so I know my gradient is equal to minus 3 over 2. That's what I'm looking to do. So, and I know that for parallel gradients, they are equal. So parallel gradients are equal. So I'm going to be using that gradient there to work out the equation of the line. So I'll substitute the gradient equaling minus 3 over 2, and the point I'm going to substitute in is 4 minus 5. Hope that still appears on the screen. Yes, it does. And I'm going to put that into y minus b equals mx minus a. Right then, so I've got minus 5, so that's going to make a plus there. I've got minus 3 upon 2 x minus 4. Right, as I was saying before, getting rid of that fraction, I'm going to multiply the left hand side by the 2, and that just gets rid of that right away, okay? I'm then going to multiply the right hand side by minus 3, so that's going to be minus 3x, and that'll be plus 12. I'm going to tidy it up a bit. I'm going to grab that and bring it over to the left hand side. I'm going to take that 10 over to that side there, and it'll be a minus 10, so I've got 12, take away 10, and that should give me 2. Okay, that's 2 there. Okay, so that's the equation of the line there. 2y plus 3x equals 2. Alright, so that's question 4 complete. Looking at some parallel gradients, and what we're looking at in this question here, we're looking at some perpendicular gradients. Right, so we have to prove that the lines with equations, this here and this here, they're perpendicular. So what I have to think about when I'm doing this question, I know that when I multiply two gradients together of lines that are perpendicular, then if that equals minus 1, then the lines are perpendicular. If it doesn't equal minus 1, they're not. Let's work out the gradients of each of these. So we'll take the first line. So it's y minus 5x, y equals minus 5x plus 2. So I've got that already in the form of mx plus c. So my gradient there is going to be equal to minus 5. Next line, I'm going to have to rearrange that to find out the gradient. Right, so I'm going to just take that 10y over to the other side. So I've got 2x sitting there. Bring the 15 over to this side, becomes a minus, and that's 10y. I'm just going to rewrite it round, okay? I'm not going to do anything in this line, just swapping it round, swapping over. I'm going to now divide by 10, so y is equal to, let's see where we are. Let's see, we've got 2 over 10, x minus 15 over 10. Dividing both things. Remember, that gives me my my c value, and the c value is the point of intersection of the y-axis. So that's going to be equal to a fifth x, and that's going to be minus 3 upon 2. So my gradient is equal to 1/5. So I'm just going to grab that, because I've got that in the form of y equals mx plus c. I'm going to multiply my gradients together. m1 times m2, right? Gradient 1 is minus 5. Multiply that by 1 over 5. What we'd get there is minus 5 over 5, and that simplifies down to minus 1. So just a statement, since gradient 1 times gradient 2 is equal to minus 1, the lines are perpendicular. Okay, so that's question 5 then. Let's have a look at question 6. So this will be the last one in this set of this video here. Right then, so question 6. Right, I'm going to stop it here. I'm not going to go for question 6 in this video. I'm going to keep question 6 and 7 together. So hopefully that's clear on questions 1 through to 5. Hope that helps you out with the assignment. This is revision for higher maths. We're looking at the straight line assignment, and at this point we're at questions 6 and 7. Questions 1 to 5 done in the previous video. Right then, let's have a look at question 6 here. Okay. Right, the line PQ has endpoints. P is 6 minus 5 and Q is minus 2 minus 3. find the equation of the perpendicular bisector. Right, let's just draw out what that should look like. Okay, so let's go for this here. Okay, so what I'll go for is I'll go 1, 2, so that's going to be 6 along, and I'll just say that minus 5 is there. So that looks like P is 6 minus 5, just doing a sketch. And I've got minus 2, so somewhere about there, minus 3, so down about here somewhere. So that would be Q, and that point there is minus 2, minus 3. Okay, just join that with a line. Okay, so there's the line that we're talking about. So what we're interested in doing when we're trying to find out the equation of a perpendicular bisector. Now a bisector is going to cut PQ in half. So first thing I'm going to try and do is find out a midpoint. So somewhere about there, is that okay? Right, so I'll call that M, right? So in that midpoint I'm going to be then trying to work out the perpendicular, which is at right angles. So the perpendicular bisector is the equation of a line that's going to be at right angles to PQ. So this line here is the equation that I'm trying to find. So the steps that I'm going to go first of all for, I'm going to find that midpoint there. So midpoint is going to be equal to, so it's a midpoint of PQ. And I'm just going to get the coordinates. What I'm going to do is take the mean of the x coordinates. So I've got minus 2 plus 6 all divided by 2. And I'll take the mean of the y coordinates. So that's minus 3, and that's going to be plus minus 5 all over 2. Right, so all we're doing is dividing them by 2 basically. So I've got 4 divided by 2 is going to give me 2 for that coordinate that's there. And I've got minus 8 over 2, which will give me minus 4. Right, so that's my midpoint, this one here, so that's 2 minus 4. And that's the point that I'm going to have to use, because that's the only point I know on that perpendicular bisector line. Right, so I need the gradient of this line and the point to sub into the equation of a straight line. So I'm going to get the equation of PQ first of all, or the gradient of that. Once I get the gradient of that line, I'll just find the perpendicular gradient from it. So the gradient of PQ, first of all, is going to be equal to y2 minus y1 all over x2 minus x1. So I'm going to take, let's start with that one there. So I'll go for minus 5, and I'm going to take away minus 3. I'm going to then go for 6, which is my x coordinate, and I'm going to take away minus 2. On the top, that's going to give me minus 2, and that's going to give me 8 on the bottom, so that gives me a gradient of minus a quarter. So with that minus a quarter gradient, what I'll do is I'll work out the perpendicular gradient. So I've just got a wee right angle sign there, and that's going to be equal to, all I'm going to do with this is flip it over, which will be 4 over 1, and change that sign to a positive. So that's going to just give me a gradient of 4. The other way I could do that, I could calculate it through the gradients. So I'm just going to say for that, it's since gradient 1 times gradient 2 is equal to minus 1. I've just used that property just to work out that gradient there, the gradient of 4. What I'll then do is I'll substitute the gradient of 4, and any of the points I'm going to have to use this one here. That's the only one I know that's on that perpendicular line. So I'm going to substitute the point M, which is 2 minus 4, and I'm putting that into the general equation of a straight line that you need to remember. Okay. Right, so that's going to be my A value, that's my B value. So minus 4, so it's going to give me a plus 4 there. I've got a gradient of 4, x minus 2. What I'll do is I'll just multiply out the right hand side, and I'll gather that 4 over to that side there. So that'll be y is equal to 4x, bringing the 4 over, that will give me minus 12. Okay, so y is equal to 4x minus 12 is the equation of that line there. Okay, gradient of 4, and I'm sure it's going to cut down here at the point 0, minus 12. Okay, question 6 complete. Let's look at question 7. Right, we're going to draw this one out. So triangle ABC has vertices 2, 6, minus 7, 4 and 4, minus 8. let's draw this up, okay? Right, so we're drawing down this side here. Okay, so A is 2, 6, so I'll go for 2, 6 up there, okay? So that will be 2, 6, that's A. Okay, B is minus 7, 4, so minus 7 and I'll go up 4, so we'll just say it's about there somewhere. So that's going to be B minus 7, 4. And for C, I've got 4, so 4 along and minus 8. So it'll be down here a wee bit further than that, but I'm just going to maybe watch out because I might need this space here. 4 minus 8. Okay, just join that up to form our triangle. There we go. One there, and there, and lastly across to there. Okay, so that's my triangle. So what I'm going to do is I'm going to try and find out the median. So the median is a line, in this case it's going to go from B to AC. Quite often you just hear the median from B, so it has to start at B. So what I'll do is I'll go to the point B, and what I'm looking to do is to go across the triangle to the other side at the midpoint. So I'm going to try and find the midpoint. So middle of this one here should be, say I guess it's about there somewhere. Okay. Right, so I'll draw my line in from there to there. Just draw this one in red, okay? So from there to there. Okay, and we're going to call this the point M, and I'm going to work that one out as well. So for a median, if I could look at what I've got here is, I've got to find out the gradient of this line here. So I need to find that point there, and that's the midpoint of these two. So find the midpoint of AC. So for part A, first of all, we'll find the midpoint of AC. I'm going to add the two x coordinates together, divided by 2, and I'm going to add the two y coordinates together. So 6 plus minus 8 all over 2, and what that should give me is 3, and I've got minus 1. So the coordinates here will be 3, minus 1. What I'm then going to do is I'm going to find the gradient between these 2 points for a median. So my gradient, and that's the gradient of BM. Remember it's y2 minus y1 for the gradient, all over x2 minus x1. So I'll start with this point here, so that's going to be minus 1, take away 4. That's all going to be over 3, take away minus 7. Minus 5 on the top, get 10 on the bottom. What that's going to give me is a gradient of minus a half. Right, so I know the gradient of the line, I know 2 points on it, so all I need to do is to substitute them into the equation of a straight line. So substitute the gradient is minus a half, and the point that we'll choose, we'll go for the, why don't we just go for the point B, the one that we were given originally. So the point B, minus 7, 4, put that into y minus b equals m x minus a. Right, so y minus 4 is equal to the gradient, x minus, and that's going to be a plus 7 that's going to appear in there, because that's going to be a minus minus together. To get rid of the fraction, multiply the left hand side by 2, multiply the right hand side by the minus 1, so that'll be minus x, and that'll be minus 7. Just tidy it up a bit, so it'll be 2y, bring the x over to the left hand side, take that minus over to the right hand side, and it becomes a plus. So that'll be equals 1. So that'll be part A complete. So that's the equation of this line here. Right, for part B. So for part B you have to find the equation of the altitude from A to BC, or basically the altitude from A. So what I need to do there is, starting at A, I'm going to go across the triangle to the line BC. The way I'm going to go across, I'm going to have to meet this line at right angles for an altitude. So something like that there. So that's the altitude. So that's going to meet this line at right angles. Okay. So it's very rare that you're going to find out what this point is here. not going to find that one out in this case. What I'm going to do is I'm going to try to find the gradient of this line. I already know a point, so I can substitute a point into the equation of a straight line. I just need the gradient of that line. So where I'm going to get it, gradient of this line here, BC, flip and change it, and I'm going to get the gradient of that line. So let's go ahead and do that. Right, so first of all, we'll get the gradient of BC. Gradient of BC, remember it's y2 minus y1 for a gradient, all over x2 minus x1. Right then, let's go for, we'll start with minus 8, and I'll take away 4, all over 4, and I'm going to take away minus 7. What I've got there is that'll be minus 12 on the numerator, and on the denominator I've got 11, so it's minus 12 over 11. So to get the gradient of this line here, the altitude, I'm just going to flip that over, and what I'll get is the gradient of the perpendicular to BC is going to be equal to 11 over 12. So I'm just flipping it over and changing the sign to a positive. Or I can work it out through calculation, which would be multiply gradients together, and I would always get minus 1 for perpendicular lines. Next, what I'm going to do is I'm going to substitute the gradient that I've got now, 11 over 12, and the point that I have. So the only point that I've got is the 2, 6, which is the point A, and I'll put that into the general equation of a straight line. Right then, so let's put our values in. So it's going to be y minus b, so b is going to be 6, and that's the gradient is 11 over 12, a strange gradient, and minus the 2 that's there. What I'll do is I'll multiply to get rid of this fraction that's here, multiply the left hand side by the 12, so that's going to be 12y minus 72 is equal to, now I'm multiplying the right hand side out by the numerator, which is 11, so that's 11x minus 22, and just tidy it up a bit. So I've got 12y is equal to 11x, bringing that over to this side will give me a plus 50. So the equation of the altitude is going to be 12y is equal to 11x plus 50. And that's questions 6 and 7 complete. Next video I'll do questions 8 and 9 together, and that will be the assignment complete. This is revision for higher maths. It's the straight line assignment, and I've already completed the videos 1 to 5 for questions 1 to 5, and for also questions 6 and 7. Now we're going to do questions 8 and 9, and that will complete this assignment. Right, so question 8 is quite a meaty question. So we've got a triangle PQR, and we've got the vertices stated. We have to find the equations of two perpendicular bisectors, and then we're going to try and find out where they cross over. That would be the point T. So and we'll do that by simultaneous equations. And then as an extra part, we're going to show that P, T and Q are collinear. Right, so let's go ahead first of all and work out the perpendicular bisectors part. For each of these I would expect to get 4 marks, so there's 4 marks for working out a perpendicular bisector at a higher level. Right, let's go ahead and start doing this one. I'm going to do a quick sketch of the situation that we've got. So what I'll go for is, I'm just going to make it quite small because we're going to run out of space with this question, I would expect. So let's see, that will be P, that will be Q, and that one there is going to be R. So I'm going to go for 2, 3, so 2, 3 up there somewhere, so that's going to be the point P, 2, 3, and the point Q is going to be minus 3, minus 2, so how about going to there, so that's a point Q, minus 3, minus 2, and the point R, which is just 3, 0, so that'll be about there somewhere. Okay, so that's R, and that's 3, 0. Okay, just draw up the triangle from there, just so I've got an idea of what the situation is. There we go. And it is just a sketch, so I've not got it exact, but I'm just trying to get an understanding of what we're going to be working with here. Right, so perpendicular bisector. Bisector cuts the line in half. Okay, so I'll do the RQ first. So that'll be this one here. So what I'm going to try and do is find the point here. So that'll be the midpoint. So that'll be the point M. Then from there, what I'm interested in doing is getting a perpendicular line from that point, which should take me up here somewhere. So it'll be somewhere about there, I would expect. Okay, because that's going to be at right angles. Let's go ahead and we'll work this one out first. Okay, so over this side here, the first thing I'm going to do is I'm going to find that point, the midpoint. So for part A, the midpoint of, let's see, it's going to be RQ. Is going to be equal to, I'm going to add the two x coordinates together, so it's going to be minus 3 plus 3 all over 2, that's the x coordinate, and I've got the two y coordinates together. So let's see, I've got minus 2 plus 0 divided by 2. So what that should give me is the point M, which will be, so that's going to be 0, and that's going to be minus 1. Okay, so 0 minus 1 for this point here. So it's 0 minus 1 now. Right, so what I'll then go for is, once I've got that point, I want to find the gradient of this line. The way I'm going to get that is gradient of QR and then perpendicular. Gradient will be just the gradient flipped and changed. Okay, so let's go ahead and get the gradient. Gradient of RQ is going to be equal to y2 minus y1 all over x2 minus x1. Right, so let's start with 0, take away the minus 2, all over 3, take away the minus 3. So that will give me, on the top it will be 2, and that's going to give me 6, so that should give me a gradient of a third. Perpendicular gradient for this one, so the gradient of the perpendicular is going to be equal to, so I'm going to flip that over, so it's 3 over 1, which just becomes 3, and I'm going to change it from positive to negative. And that's just since the gradient 1, gradient 2 multiplied together equals minus 1. Okay, I can always calculate it out, but that way there works out just fine. I'm going to try and work out the equation of the line, so I'm going to substitute the gradient. So I'll substitute the gradient of minus 3, and the point I must put in is the 0 minus 1. And I must put that into y minus b equals m x minus a. Okay, so let's put that in, we'll get our equation. So y minus b, that would be a minus 1, so that would be a plus 1 going there. The gradient is minus 3 x minus 0. So just to work this one out. And what I'll do is I know I'm going to be using simultaneous equations, so I'm going to get my y and my x's onto the left hand side, and I'll put my numbers on the right. Okay, so that's going to be a minus 1 there. Okay, so that's y plus 3x equals minus 1. Okay, and that one there is going to be my equation number 1 that I'm going to use in my simultaneous equations. Right, let's work out the perpendicular bisector of PR. So again, there's P and R. So if I look for the perpendicular bisector of that one there, it's going to go from here. So I'm going to find the midpoint first of all, same type of thing. And what I'll do is, must be something like there. Right, this is just a sketch. So this point might not lie there. It might be quite close to it, but at least I'm getting an idea what the situation is. Right, so what I'm going to do is find the midpoint. So I'm going to repeat what I've done up above, just for the P and R, so PR. So midpoint first of all, so adding the x's together, divided by 2, just taking the mean, and the y's together, divided by 2, that should give me, it's going to be 5, so that's 5 upon 2, and that's going to be 3 upon 2. I'm going to leave it like that, I'm not going to put it into a decimal of any sort. Just going to leave it as a fraction like that. I'm then going to do the same again. I'm going to work out the gradient of the line that's here. So I'm going to work out the gradient of PR. And that's y2 minus y1 all over x2 minus x1. Substituting some values in, so 0 minus 3 and 3 minus 2. So that'll give me minus 3 on the top, and that's going to give me 1 on the bottom. So that'll give me a gradient of minus 3. So a perpendicular gradient for that one there. So the gradient of the perpendicular is going to be equal to, so if I imagine that's a 1 over the top, or I don't need to, there it is there, flip it over, so that's going to be a third, and I'm going to change it from negative to positive, so the gradient's a third that I'm going to use. Right, so I'm going to substitute that into y minus b equals mx minus a. And when I substitute that in, what we're going to get for that is y minus, and the point I'm going to be using is the midpoint, so that's going to be 3 over 2 is equal to the gradient, which is a third, x minus a, which is going to be 5 upon 2. So I've got quite a bit of fraction work that I'm doing here. Right, so the first thing that I'm going to do is to multiply through by that 3 on the left hand side, multiply by 1 on the right hand side. So what I'm going to get here is, I'm going to get 3y minus 9 upon 2 is equal to, and that's going to be x minus 5 upon 2. And then when I sort that out, what I'll get is, I'll get 3y on this side here. I'll bring the x over, so it'll be 3y minus x, and on the right hand side I've got minus 5 upon 2, and if I bring that over I'll get positive 9 upon 2, and from there I can see that my equation of the line is going to be 3y minus x, and that's going to be 4 over 2, which will leave it as 2, and that's going to be my second equation. That's my second equation. Okay. So that won't be the same as the answer that you've got in the answer sheet. I think the answer sheet gives us as double each of these values, so it'll be like 6y minus 2x, and it'll be equals 4. So it'll be like that. So for part B, okay, part B, what we're going to do is we're going to work out the find the point T, the point of intersection. So it's this point here, wherever that's going to lie. So it's going to be somewhere about that area there. So I'll grab my equations together. So this one here, y plus 3x equals minus 1, and this equation here, which is 3y, that's minus x, is equal to 2. So that was my equation 1, that one there's my equation 2. Right, to solve this system of equations, what I'm going to do is I'm going to multiply equation 2 by 3, and then I'll get a positive 3 there and a minus 3 there, and I'll be able to eliminate one. So I'm going to multiply that by 3. So equation 2 times 3, that'll give me 9y minus 3x is equal to 6. That's now my equation 3. What I'll then do is I'm going to work, let me just kind of segregate some of this out the way. There we go. Right, so what I'm going to do here is I'm going to add these together, because if I add equation 1 and 3 together, I'm going to eliminate the x's. So I'm going to go for equation 1 plus equation 3, so that will give me 10y, the x's disappear, and what I've got here is I've got 5. So I can see that y is equal to 5 over 10, which remember equals a half. So y is equal to a half. That's my y coordinate. I'm going to substitute y equals a half into, and let's just go straight into equation number 1. So what I've got there is a half plus 3x is equal to minus 1. So 3x is equal to, so if I take that, that half over to the other side there, that will be minus 1.5, so that will be like minus 3 over 2. And then what I'll do is I'll just divide by the 3. So that will be minus 3 over 6. Because if I divide by 3, I'm bringing it to the bottom over here, so that will give me a 6. So what I've got is x is equal to minus a half. X coordinate minus a half, x is the y coordinate is a half. So the point T is going to be equal to minus a half. Okay, and that's that part complete. So that's part B. Right, we'll now look at part C. If my pencil works. Part C. Okay. Hoping to get started in a wee minute. Right then. Right then, let's go for part C. So show that P, T and Q are collinear. Okay, so for collinearity, I know that the gradient between PT and the gradient between TQ must be the exact same. So I'm going to just work out the gradient of PT first. So my gradient of PT is going to be equal to y2 minus y1 all over x2 minus x1. Substituting the values in. So the point T is this one here. Okay, and I'll go for 3. So it'll be 3 minus a half all over, and I've got 2 minus a half, which should just be plus. So what that should give me there is 3 minus a half will give me 2.5, which will be 5 over 2, and 2 plus a half gives me 2.5, which is 5 over 2. That just gives me a gradient of 1. Okay, just bring that over a bit. So that should give me a gradient of 1. So if I work out the gradient of TQ, I'd be expecting that that's going to be the exact same. So I've got y2 minus y1 all over x2 minus x1. Let's substitute the values in. So I'll go for a half, which will be from t plus 2, and I've got minus a half on the bottom plus 3. That's going to work out to be the exact same. 5.2 on the top, 5.2 on the bottom, and that equals a gradient of 1. I'll then just make a statement to that effect. So I'm going to say that since the gradient of PT equals the gradient of TQ, and they both equal to 1, with a common point, and the common point is T, because in these both calculations I've got T in both of them, so it's a common point T, and we must state that, you know, that the common point T is used, then the points, and it was P, T and Q are collinear. Okay, and collinear means that they're in a straight line, or they're lined up in a straight line. So that's why the gradients are exactly the same. Okay, so my drawing could have been a bit better to try to make sure I could see that. So if I drew it out a bit better to scale, I'm sure I would have got the point coming out over here somewhere. But that's the calculations. You can do it without a drawing, but a sketch always kind of helps to try and determine what to do. Phew, that was quite a long one. Let's go for question 9. Okay, question 9. This is the last one. Right, so ABCD is a parallelogram whose diagonals intersect at E. If A is equal to B and E are these points here, so that's going to be A, that's going to be E, and that's going to be, no, that's going to be B, and that's going to be E. Find the equation of DC. So again, what I'm going to do is I'm going to do another sketch. Okay, so a sketch here. Right, so I've got A is minus 1, 0. So let's go for minus 1, 0. Okay, so that's A. Okay, I've got B is 3 along the way, so I'll go for 3 along, and we'll go for minus 2. So minus 2 would be about there. Okay, so that's going to be B. B is 3 minus 2, and A was minus 1, 0. Okay, and we've got the point E, which is going to be 1 along, so I'll go for 1 to there, and we'll go for 4 up. Okay, and that's going to take us to there. So that there is the point E, and the coordinates of E were 1, 4. Okay, right, so we've got a parallelogram. So I've got A, B. That's the the midpoint of it, or the midpoint where the diagonals intersect. So what I'm expecting would be I've got AB here. Okay. And what I should have is through there, I should have where the D is going to lie. Through there is where C lies, because it's A, B, C, D. So A, B, C. C is going to be up here and D is going to be up here somewhere. Let's try and work out these coordinates to work out the equation of the line DC. Now what I'm going to do is I'm just going to count on to try to work out these coordinates. So let's find the point C first of all. So the point C is up here somewhere. And if I think about that being where the diagonals intersect, I know that if I go along 2 places and then I'll go up 4, all I need to do to find C is do the same pattern, okay? Because all I'll be doing is finding the point that's up there by moving along 2 and moving up 4. So if I go along 2 on to 1 is going to give me 3, and going up 4 from 4 takes me up to 8. So C is going to be the coordinates 3, 8. I'm going to do the same from B through E to find D. So I've got D up here somewhere. Right, so from B to E, if I think about that, so I'm going to move 2 places that way, and I'm going to have to move 6 places up to get to E. So 2 along and 6 up, so 2 along that way would take me to -1, and 6 up from there will take me to 10. Okay, so that will give me the coordinates there of -1, 10. So that will be my point D there. Okay, so -1, 10. So that's maybe about here somewhere. Right, I can then just draw this up. And this here will be my parallelogram. Okay. Right, so what I've been asked to do is to find the equation of DC. So that will be the equation of this line that's running along here. So what we'll do with that is, we've got the 2 points, so we can work out that quite easily. So what we'll do is we'll work out the gradient first of all. The gradient of CD, y2 minus y1, all over x2 minus x1. Substitute points in, so 8 minus 10 and 3 minus -1. That should give me -2 on the top, and what we've got is 4 on the bottom, giving me a -1/2 gradient for this line here, which looks about right, just based on that kind of drawing. Right, what we'll do is we'll substitute that gradient that we worked out of -1/2, and I'm just going to choose one of the points. The point that I'll choose, let's go for the 3, 8, 2 positive numbers there, so it'll be the point C. 3 and 8, doesn't matter, you could have put that point in and worked it out. Fire it into y minus b equals mx minus a. All I'm going to do is get, that's my a value, that's my b value, so -8 is equal to -1/2 x minus 3. Okay, so from there I want to get rid of this fraction, so I'm going to multiply the left hand side by 2, multiply the right hand side by the -1, so it'll be -x and that'll be +3. I'm going to gather that up, so I've got 2y, I'm going to bring the x over to the right hand side just to make it a positive number and take the 16 over that side, so that'll be equal to 19. So 2y plus x equals 19. Oops. Right, so that's how to go about some of this revision, the revision questions for the assignment, questions 1 through to 9. Heavy marks there for question 8 in particular, bit of problem solving for question 9, some of the basics 1 through to 5. So hopefully that's helped you with some of your revision on the straight line topic.